All right. So I thought I would be funny and wear my circus shirt today for no apparent reason. Yep. Absolutely no apparent reason. Repack! But that's not the topic of today's video. Today we're gonna talk about derivation paths. I just want to give you some basic understanding of derivation paths because in the beginning there was something that I just didn't understand, and now I have a decent understanding of it, so I want to share it with you because that's just one of the things that you come across time and time again, and if you understand it, it's easy. A few disclaimers before we start. This is just gonna be an introduction to derivation paths. I am not an expert on that topic. I also just learned myself, and in the 2 years of being in crypto, I now have a somewhat usable understanding of it. Also, the concept of derivation paths is used on several systems and different blockchains. And today we focus on Solana here. So we're gonna specifically be talking about derivation paths on Solana. All right. Should we just get started? And maybe I'll start with an outline of why the hell do we even need that? So let's start with a little recap. This is stuff that you should already know. What is a key pair? It's a combination of a private and a public key. There's a public key, also known as the address on Solana, and a private key that can be used for signing a transaction. So basically, if you hold the private key, then you can prove that it's your address, and therefore you can send the tokens or SOL away from this address. So your one wallet address, which is a public key, has one private key associated with it. And both together, we call it a key pair. Cool. And on Solana, if you want to create yourself a key pair, you can use the solana-keygen. For instance, solana-keygen new. And then we can define where we want it to go. My key, JSON. I can put a passphrase for the recovery seed, not for the key itself, because that will be plain text. And then we have public key, and the private key will be in my key.json. So that's the private key. Note to everyone, don't share your private key like I just did, because as soon as somebody has the private key, they can claim all your stuff, all the things. Now, what do we have here then? This seed phrase, and that thing is used to derive the private key. So essentially you start with this, and this is a human readable string. Those are just some words to make it easier for humans to, note that down than it is with numbers. But basically from those words, with a given set of rules, you can make essentially a number again, and that number is then used to derive the private key. So we're getting closer to where we want to go, deriving. What does that even mean? When I say derive, you have something and then you do some mathematical operations and then you get something else. The same way that the public key is actually derived from the private key when we do Solana address given a key, that operation just performs a mathematical calculation and it takes that as input and produces that as output. So it derives the public key from the private key. Same way that we can derive the private key from a seed phrase like this. Derivations. Okay, getting there. Maybe let's actually do this. Let's use this seed phrase here and derive the key again. So that would work with solana-keygen recover. I already automatically want to write grind. I'm so used to writing grind. Then we specify where we want it to go, recovered, and press enter. Then it asks us for the seed phrase. I'm going to paste that in here now, hit enter. Then it asks us if we have used a passphrase for it. No, I have not. So I press enter again. And then it tells me, oh, that is the public key that you would recover. Is that correct? And I was like, yes, that is correct. Enter. And then it actually wrote that. So now we can see that we once again have derived the same private key from a given seed phrase. Cool. So that's one key from one seed phrase. So far, so good. We're still stuck with the basics. When we would now create ourselves another address, another key, we would do solana-keygen new again, or maybe even solana-keygen grind and grind ourselves an address. And then we need to remember another seed phrase, which in some cases works just fine. But in other cases, we don't want to remember so many key phrases. You don't want for every address that you use, have to remember another seed phrase. It would be much nicer if you could just use one seed phrase and derive several addresses from it. So several private keys that each have their public key. And that's where derivation paths come in. We have already used the derivation path, but we didn't specify, we used the default one. Let's look at it. Keygen, recover. It's hidden in the prompt, I think. Let's look at it here. Paper wallet. There, hierarchical derivation. I think that's what we want. Yes. We can derive a hierarchy of private keys from our seed phrase plus passphrase by adding the key or the full path. And the key is just emitting the default, but this is getting ahead too far already. Let's just start with the key. We can define which derivation path we want to use. And that doesn't only work for finding out the pub key, but also for recovering the actual key. So I can also do this with recover and provide the path with prompt pub key, by the way, derives the public key from a seed phrase. And I need to say, where does it come from? I will put in the same seed as before. That's weird. Gives me a completely different address now. If you need, you can access legacy by instead passing the ask keyword. Ask. Aha, okay. So the legacy way of doing things with the legacy derivation path, we get our expected public key again. And that's another one with another derivation path. We'll get there, don't worry, I'll cover this. I'm just trying to structure it in a way that is understandable and easy to follow. And I don't want to confuse you right from the start. So let's just start with this. We can provide different paths, let's say, and then with the same seed phrase, we can derive different public keys by deriving different private keys first. Well, really, from the seed phrase, we create a master key, and from the master key, we create several private keys, and from those private keys, we can then derive the public key. That's how that works. But, like, point is, we can prompt key 0 and then put in our seed phrase. Then we get this 5TFY. The way how to properly write this is question mark key and then 0. There we go. Now we already get a different one here. With key 0, we get the DLN. With key 1, we get the BM. With key 2, we get the 2E, and so on. So we can have several public keys from the same seed phrase. This command, by the way, now just derives the public key. If I want the private key, then I can do the same. I just don't say public key, but recover, and then write it somewhere, and I put in that. And then it saves me the private key for this address. So that was now with derivation path 2, this the public key. And just to double check, if I were to find the address for this temp JSON, then this would also give me the same. And that's the private key now. So that's the private key we recovered from the same seed phrase, but we were providing a different path, a different derivation path to get a different private key. And that's the basic idea already for why do we need derivation paths. So we can have one seed phrase and have multiple actual addresses, which can be very helpful if you have paper wallets, like where you just write down your seed phrase on a piece of paper or maybe even some steel, whatever. And then you just use that to derive your private keys. So you don't need to write a new seed phrase for every goddamn address that you want to use. Same thing with ledgers. Your ledger you also just set up with one. And from that, the ledger can derive the master key And from that master key is then used to create a bunch of addresses, as many as you like. Master key is also a private key, but it's the main private key to derive other private keys. Does that make sense? Did I convey why we need derivation paths? I hope so. That's a general idea now, but what does that even mean here? This key 2. Let's get a bit into the details of that. The full derivation path actually looks like this. So we start with m/ then purpose, coin type, account, and change. For Solana, the first two are given. Solana's base derivation path is 44501. So the purpose and coin type are already given. And then we just fill in account and change. So we say key equals account and change, which means what we just did here is the same. So this thing is the same as if we say full path and have m/44501 and then the 2. There we go. That gives us the exact same address. And this thing here means that it's hardened, but on Solana, on this ED25519 curve, everything needs to be hardened anyway, so we can omit that because it's automatically hard. Don't ask me what that really means. I did not really find that out yet. All derivation path indexes will be promoted to hardened indexes. So it doesn't matter if we write them or not, they will always be hardened. So they will always be ticked like that. Right, so far we only used account. We can then also add another one, the change. So we can be like 2/0, do the same thing. We get another one, 2/1. We get another one. You know, plenty of possibilities to derive addresses. Maybe one interesting thing is also that 0/0 is a different one than just 0 and is a different one than no 0 here either. They're all different addresses. And we can use a similar coin type here, for instance, which would again give us a completely different address. But the standard for Solana is to use the 501. So let's stick with that and just keep using the key 2/0. That will again give us the same thing as if we have the full path 4450120. Okay, cool. Where do we go from here? If you have an actual paper wallet and you want to take security seriously, you should do that on an air-gapped computer, so one with no internet access, to derive all those public and private keys. And see, that makes sense. Like, you could have your paper wallet, so your seed phrase that you store somewhere securely, and then just on a secure, so like an air-gapped computer, for instance, on a secure machine, derive a private key with one derivation path, and then take that private key to a hot machine and use it there. Because then the worst that can happen is that you lose this one private key, that is compromised, and then you lose one address essentially. But your remaining addresses, the ones that were created with different derivation paths, they are still safe. Yeah. I hope that you get this stuff now. So whenever you see 44501, then you can now think, derivation path. Actually, maybe let's have a look at how some standard wallets do this. Standard? Some popular Solana wallets. Because I don't want to ruin my setups here, I'm gonna use a new browser with a new profile. Yeah, I like purple. Very purple. And I'm gonna start by getting myself some extensions. So we've got Solflare and Phantom. Let's start with Solflare, why not? And say I already have a wallet. And we put in the same key phrase as we had before. Same seed phrase, 12 words, continue. And after we put a password, it will give us this quick setup or advanced setup, and we're gonna use advanced. And here we already see derivation paths. Remember that? M44501, M44510, M4450100. Remember those? And also Have we seen those before? Yes, we have. We know what that is. If we didn't provide any path, then we get the 5tfy. If we didn't provide any path, we get the 5tfy. If we provide key equals 0, then we get the DLN. DLN. If we provide 0, change 0, then we get the ATX. ATX. So that's those keys. And now on the 44501, there is only one address because you can't have more. If I click on that, there's only this one address that I can choose from. I can select it or not select it. That's it. But if I go here, for instance, in the /0, here I will find more wallets. Why? Because at the /0, I can exchange the 0 with a 1 or with a 2 or with a 3 or with a 4. And that's what's happening here. So this is 44501/0. This is 44501/1, 44501/2. Remember, with a key equals 2, that was that address. 3 would be this, 4 would be this, 5, 6, 7, 8, 9, 10, and so on. So 11, 12, if I wanted to have the 3KK, this address, if I were to import that on Solflare, and I wanted to have the same as a file system wallet, because I have the seed phrase, I could be like what did I count to? 12. Boom. Provide the same seed phrase, and there we have it, the 3KKZ. And Solflare allows us to go one step further. We can also use the 0/something. So now those addresses, they all have 44501/0 and then the next index. So the 8T, that would be the 0/0. Remember, that's the 8T. And then the next one, 0/1. I keep confusing that. That's true. That forgot what I said. It's the other way around. It's not 0/1. It's 1/0. That's then the 9AO. That's this one. And then the next one would be the 2/0. So that would be the 2/0. Here we get the CP9. That's the CP9. And so on and so on. So all of those are the 44501, and that one then changes /0. And different wallets do that differently. That's why sometimes I get confused. Why can I find one wallet address here, but not on another wallet? Because of derivation paths and how they handle it. Let's see how Phantom does it. If I say I already have a wallet, put in my same. Cannot paste? Are you fucking kidding me? You're really shitting me, Phantom? I cannot paste this? Denied. Typing exercise. Okay, better works now. Import wallet. Now it lets us choose accounts. Phantom is a bit more obscure with which accounts those actually are, but we have already kind of seen this, but also not really. This address seems familiar. This address seems familiar, right? There was the 00. There was the 10. There was the 20. So Phantom seems to do it the same way that also Solflare uses the last one here. So if I wanted this address, I select it. Then, because that's maybe also interesting to know, I want this Euro address now. I say continue. I've got the 00 and I've got the, where's the other one? Here, I find the other one. Cool, it already displays it like this. That account 81 is that Euro thingy. Euro. So 82, if I want to get the account 82, I need to use the key 81 because we start at 0. So let's check if that is actually true. 81. Nope, it's not true. Oh, it is 82. But I remember on my ledger I was always off by 1. Doesn't matter. Maybe Solflare changed that. Okay, so account 82, and it says account 82. account 82. If I put 82 here at the account, then it derives me this. So can I get the same one on Phantom? I just need to scroll down to 82. Phantom won't allow me to go further than this. And they will also just call it wallet 1, wallet 2. But I can't display information about that. And if I say create a new account, it will just use the next available one. That's also a bit annoying. Because if you don't know that Phantom uses the same seed phrase all the time, then you essentially are screwed. 5Q, if I do it again, then it will give me the H set. I want yet again a new account. It will give me the H. Yeah. Okay. Don't like Phantom anymore. It used to be the best wallet, but the usability has lagged behind. Or others caught up, let's put it like that. I reset my wallet again and do that typing exercise once more. Because Solflare really does a better job of displaying this. Okay, so here we can compare. It's the same thing still, but it stops being the same thing. Hold on. Here, at 20, it stops being sync. The 6 kVe, and then here I have the DLNP, and here I have a DB something. So this one, the 19, is the last one that is still the same. I'm gonna get on to the bottom of this. What are Phantom derivation paths? But haven't we also seen the DLNP before? This kind of looks familiar. So the 19, 6 kV ending in 5. Yeah, that's still the same. And then the 20 is the one that Solflare has, that Phantom doesn't have anymore. So this Solflare continues with the account, and then Phantom does something different. What do they do? DLNP. Haven't we seen that before? Wasn't it something like 01 or something? No. Ah, wait. But that's BMH. BMH. Haha. Okay. So it was the 0. It was the just 0. That was it. It was the just 0 and then just 1 and then just 2. Yeah, those are the ones now. DLN, BM, 2EJ. That's what's up here now. 3 without a charge, 4 without a charge, 5, 6, 7, 8. Let's check if that's still correct. 8 without a charge would be FCX. 8 without a charge would be FCX. 12 without a charge would be 3KK again. Haven't we seen this before? Wait. Haven't we seen? I mean, I can't add them here like this anymore. Here I am already in the charge. But if I were to log out, I need my recovery phrase to be able to log out. How stupid is that? But okay. Just making sure that I have my recovery phrase. Okay. But let's do that again. See, I have my recovery phrase. And if I go here at the 0 without the charges, that should then be the same as we have them here. Yeah. That's now the same. That still matches. And here it also ends again. Okay. I mean, don't ask me what Phantom does, but they do something weird. EAX, that's still the same. This one is still the same. And then, once again, Phantom decides to F this and do something completely different. How many were that now? If I import those two, 19. Again, 19. And this time we are on that derivation path. So I have to go 1 here. Solflare is cool. So far, we found out that Phantom essentially takes first few addresses from here, 20 addresses from here, then 20 addresses from here. And what do they do then? I don't know. BMC. Let's find out where they come from. What would I expect? I don't know. So far we had this and then this. So what's the next logical thing to do? This? No. Expect that to be exactly 20 again. Is that true? 18, 19, 20. Yes, that's 20 more. Where do they come from though? I want to find that out now. I want to play Sherlock and be like, where do they come from? But can't we Google that? What derivation path does Phantom Wallet support? we have that with the account change and the 0, then just that, and then, oh, with another 0? Oh, that's the deprecated index and then 0, 0. Maybe like that we can also find out our first address to bring it full circle. But for that, I guess I need to do full path, because that it will not allow me to do that. So let's do full path with a 501/0 0 0. Haha. FR1. Nope. Oh, sorry. My bad. They don't use the 44. Okay. They were indexing the coin type, right? The coin type, and they dropped the purpose. That's it. Okay. So they were dropping the 44, and then we get that, except also not really. That's very small, right? Sorry. There you go. So that wasn't really helping. Phantom will scan for 20 addresses in each of our 3 supported derivation paths. Okay, so that, and the deprecated path for a total of 60 addresses. So it will use the deprecated path still. Okay, I don't get it. And I think I'll give up here. Because why would I want to... Yes, I do want to understand Phantom, but why would I want to? Just in case Phantom goes bust and I used one of those addresses, which I have. I think my solandy.sol address is on one of those, actually. Can you tell me what I'm doing wrong here? Why I don't manage to get this address, the same one? I don't manage. If you manage, please let me know. Those last 20, I don't know how to get them. Which means, for me, that I will never use the last 20 addresses of Phantom anymore. Yes, that's what I learned today, lol. Among other things. Repack. Should we also check Backpack? Because at least they are open source. Open source. Now I guess I need an invite code. Good thing is that all the invite codes are now working indefinitely, so I can just grab one. Go. Temp Andy. I already have a wallet. Now we copy this thing again. Import. Say Solana. And here we once again neatly can select, I also love the colors here. Here we can neatly select the derivation path as well. Let's start here, because those should be the ones that we know. Right? Those are also the ones in here. Except, no, they're not. See, every wallet does it a bit different, so that's confusing. So the first address in here is the first address in here. That makes sense. Okay. And then the remaining are those. Okay, good. So Backpack essentially just takes the 44501 without anything, and then, so that's that one. Then the 44501 with a 0, with a 1, with a 2, with a 3, 4, 5, and so on. So those are then all the remaining accounts. So same as Solflare does, except it puts this one also on the top of the list here. That's the only difference for this one. Then with a 0, we start here. What is for Solflare the 0, 0. And we go through that list. So that's this one, this one, this one, this one, this one. Yes, okay. So that seemed to be the same ones here as well. 5K. Yeah, matches. Except that in Solflare I can just scroll indefinitely. That's why I love Solflare. That's one thing I love Solflare for being able to scroll indefinitely. And if I run out, then it just loads more. That's so cool. Anyway, so that's that. And then Backpack also supports another one that none of the other wallets supported. FR, ME, and 6. And I think that's something we already did. I'm gonna make this a bit small. That's probably this one then. Yeah. FR, and then the 1 here. ME, and then the 2 here. 6V, and then the 3. 6C. Yeah, so that's the last path for Backpack wallet, where it just adds yet another 0. So yeah, you can like have arbitrary derivation paths, I guess. You're not even limited to those 1, 2, 3, 4. You can have a 5th one. I mean, I still don't know how that works technically. I would know how to look it up if I just follow this. There's that's where it is described. If that looks like hieroglyphs to you, then that's okay, because it also looks like hieroglyphs to me, almost. Like, I understand a little bit. I mean, I have a computer science background, but still. Yeah. And then here in the references, you can find stuff like the hierarchical and how the mnemonic codes work, like how we get from the text to actual numbers. And you can read all of that up here. And here, that's the actual hierarchical wallet thingies. And that's actually a cool graphic that I wanted to show you. So we have the master seed. So that's our seed phrase that from which we can get those few bits of entropy, which then creates this master node. And then we can, that's the M. And then we can say /0 will give us that account, and then 00, that's for different wallet chains apparently, and then different addresses, and then we could add another one so we can go even deeper than this. And that, by the way, is also how your ledger from one seed phrase can create Bitcoin keys and Ethereum keys and Solana keys, right? Because they just have different paths. The BIP44 standard has the 44 and then 501 for the chain, and then different accounts in there. So can go even deeper and deeper and deeper. And how that actually works, the mathematics behind it, if you're really interested, read that. That's too far for today's video, and also for my level of understanding mathematics. Yeah, but I'm happy with what we found out today so far. We now know how Backpack and Phantom and Solflare get their addresses. We've learned a bunch about these derivation paths and how from one seed you can create practically infinitely many addresses. There's one open question about where those come from, because I didn't manage to use that deprecated path, and that's okay. I will just avoid Phantom. I'll just use those two. And with that, I think I'm gonna leave you today. I think that's enough to digest for now for an introduction to derivation paths on Solana. In one of my upcoming videos, I want to talk again about derivation paths in combination with a ledger. That's the base video, the basic understanding we need to have for understanding what we do there. So subscribe if you don't want to miss that. Also, like the video if you actually enjoyed it. Let me know if that was in any way helpful to you. I really had issues understanding derivation paths in the beginning, and I wish I had such a video to explain it to me. So there you go, you're welcome. Share it with a friend who might struggle with understanding it, or send it to yourself in the past. Yeah, and you can check out those videos, and then I will see you in my next one. Till then, keep your crypto safe, hidden inside several wallets that you derive from a seed. We can't do much against it losing its value, but we can keep our wallet safe. My crypto might lose all its value, but at least it's still mine. Good night.